Welcome back to Team O'Neill. I'm Wyatt. To the untrained eye, it really out there looks these days like there are 100 different kinds of all-wheel drive, and each manufacturer has its own, from, Audi and Acura all the way down to Volkswagen and Volvo. When in reality, there's only a few basic systems that everyone's really using, and a lot of times it's the same manufacturers behind the scenes that are actually putting these together for the car makers. In the old days you heard of ZF a lot. Now it's GKN, Torsen, Borg Warner, Haldex, there's a couple more. As a driver, you could go ahead and just separate all the all-wheel drive vehicles in the world into kind of two camps. Electronically controlled all-wheel drive that doesn't really have a center differential usually, or true mechanical all-wheel drive that's going to have a center diff, whether it's a gear-driven center diff or it's a viscous coupling and an open diff or something like that. And really those two kind of camps are going to behave very differently. So if you're looking to operate a vehicle at a very high level of proficiency and safety and maybe even some speed, you really need to know what you're working with. But also, this can advise your own vehicle purchasing decisions if you're selecting a vehicle for yourself, for your family, or if you've got something and you're not quite sure how it works. Hopefully you find this video informative. So let's take a look at the basic electronic all-wheel drive systems that are out there today, the basic fundamentals of how those work, again, from a driver's perspective as well, and then true mechanical all-wheel drive, which is becoming more and more rare these days, honestly. But what are those systems like, the few different kinds of those, and again, as a driver, how to approach those if you do need to get behind the wheel of one of those, especially if you plan on driving it on slippery roads, potentially at high speed. All right, so electronic all-wheel drive, the modern systems you're seeing out there, versus mechanical, true all-wheel drive with a center differential of some kind. What we're looking at, let's get right into the electronic all-wheel drive camp first, just because honestly, they're more prevalent these days. If you're car shopping between, especially SUVs and wagons and different things, you'll see a lot of all-wheel drive, things that say all-wheel drive on the back. A lot of them aren't all-wheel drive all the time, and a lot of them have some different knobs and stuff. So let's take a quick look at those. Once these systems were pretty rare, I got my cheat sheet here. Examples these days that you're going to find in the new and used market include, but are not limited to, roughly in alphabetical order: Acura Super Handling all-wheel drive, some Audis, BMW xDrive, Bugatti, Buick, Cadillac, Chevrolet, Dodge, Chargers and Challengers, Ford's intelligent all-wheel drive, Honda intelligent variable torque management and real-time all-wheel drive with intelligent control systems, Hyundai's H-Track, Infinity's intelligent all-wheel drive, Jaguar, Jeep's Quadra-Track and active drive systems, Kia's Dynamax all-wheel drive, some Lamborghinis, Land Rovers, Mazda's iActive all-wheel drive, Mercedes 4Active variable, Mini, Mitsubishi Super all-wheel control system, Nissan's intuitive all-wheel drive, Porsche's active PTM, Range Rover intelligent driveline dynamics IDD, some Saabs, some Toyotas, almost all modern Volkswagens, the modern 4Motion Volkswagen system, and finally Volvo's 5 different generations of Haldex all-wheel drive that they've used. So if you're shopping all-wheel drive, that's just to say that you're probably looking at an electronic all-wheel drive system. Some big indicators of that, if there's a knob in there that has a winter mode or a pavement mode or a sport mode and some of those things, that's going to change those all-wheel drive parameters. What are you really working with? The older systems and the more basic electronic all-wheel drive systems are two-wheel drive vehicles. Some are front-wheel drive, some are rear-wheel drive, but say it's a front-wheel drive vehicle, and when it senses those front tires spin, it starts to engage some of that all-wheel drive. It does this through an electronically controlled clutch that's basically between the prop shaft from the transmission to the rear diff. A lot of times it's right back at the rear differential. In normal operation, you're driving down the highway, it's front wheel drive, you get great fuel economy, less moving parts, wear and tear, that kind of thing. But the idea is that, yeah, when those tires spins, those wheel speed sensors sense that, and it'll go ahead and start engaging that all-wheel drive clutch, really, for you to help you get along. The early systems were a little jerky, you know, when that all-wheel drive kicks in, you can feel it. And the more modern systems, they do it a lot more smoothly. You know, most drivers out there on the road who have these systems don't even know. And, you know, if you're driving in the winter, a lot of people can't even feel that happen, which is good. This is exactly what Haldex is. Haldex is a private company. If you've ever heard of them, they're started out in Sweden. I don't know where they really operate from now. And again, a lot of those Volvos have generation 1 through, gosh, it's 5 or 6 or 7. I'm not even sure right now. The early systems, that's that Haldex clutch engaging to give you all-wheel drive when you need it. The more modern and higher end systems, you know, the newer generations of Haldex are a lot more advanced than that. The one thing that they give manufacturers the option to do is kind of preload that clutch pack from the factory. So items like you'll see the BMW X-Drive says, 60% rear, 40% front. Or, you know, Jaguar and some other sporty ones where it's 70 or 80% rear and, you know, 20 or 30% front. And then those systems are going to vary that power from there. The first way is just whatever mode you have it in. So if it's in eco mode, sport mode, snow mode, sand mode, rock mode, whatever it might be, Focus RS, you know, track mode, drift mode, it's going to be able to change that front to rear power bias. You know, when you get into some of the more advanced, intelligent, proactive all-wheel drive systems, there's just a whole array of sensors around the car that are feeding that computer information, and it's making changes in real time to help you out the best that it thinks that it can for whatever application it is. You know, it's going to see data from not only the wheel speed sensors, but also the steering angle sensor, the throttle position sensor, brake position. It's going to know what you're trying to do, the yaw sensors. More advanced systems are going to know when the windshield wipers are on. It's going to give you a little more all-wheel drive. If the temperature is below freezing, it's going to engage a little more all-wheel drive. So they're really kind of very automatic and seamless, and a lot of people, for very good reason, do love these systems. One thing to keep in mind is that these more advanced modern systems all work in unison with the stability control and the ABS and all of the other active safety systems in the car. So not only when a tire spins is it going to transition the power, but it's also going to be applying individual brakes to wheels and doing different things via that ABS, traction control, stability control system, as well as the intelligent active all-wheel drive. It's all working in concert. And the last puzzle piece that you'll start to see with these modern all-wheel drive systems is torque vectoring. All that means is it essentially also has clutch packs on either side of either the front or more often the rear differential. So that rear, say, has a clutch pack on either side that it can pre-tension more or less to feed power more to one side or the other. So a lot of these modern cars, it's going to be moving that power from the front to the rear and potentially side to some degree. How well do those work? Some of them work great, some of them aren't so wonderful. You're gonna have to look into you know, the specifics of every exact little vehicle, and even, you know, 1 year change to another these days, there's gonna be a significant difference in a lot of this technology. Kind of the peak of that right now we're seeing in electric vehicles, particularly, you know, hey, if you look at the Rivian trucks and things that have 4 electric motors, 1 at each wheel, it can vary infinitely how much power goes to each of those 4 wheels, you know, all 4 at once or just 1 or whatever it wants to do. The more mechanical gas burning systems, even with that torque vectoring, some of them can send up to 100% to the front or the rear, and some of them do have some of that torque vectoring, but it's not as complete and obvious and perfect as you're starting to see with some electric cars. That's a topic for another day. You know, hopefully we can get one of those Rivian trucks out here and play with it. You know, we did have one of the dual motor Tesla all-wheel drive Model 3S performances out here with wired. So you can check that online. I'll put the link in the description. That was fantastic. Be aware with the gas burning advanced all-wheel drive stuff, it's always going to be a compromise. If you're talking about a commuter vehicle and you live in California and sometimes you might take a ski trip every year, they're going to be wonderful. Don't think twice, go buy one, buy three, doesn't matter. If you're living somewhere where you see a lot of snow or you like driving a little sporty, sliding around a little bit, out to the end of that spectrum where we live, in rally cars, sliding around an awful lot all the time, these electronic all-wheel drive systems just don't work for us. This is why you hardly ever see race cars or, really specifically rally cars built out of these stock electronic all-wheel drive systems. Number one, they're just not gonna take that much abuse for that long of a time. They're designed for that street driving and then being okay in the winter if you need to get through some snow and doing their thing, but hard use, they're just not kind of built for that. So, for a real rally application, or if you wanted to go drifting with one or really push it on a track or something like that, might not be the way to go. Number two, they're just not that predictable behind the wheel as it's moving power from the front to the rear and you're spinning and you're sliding. And sometimes, if you're braking, it's going to give you only front wheel drive, or if you're accelerating full throttle, it'll lock, but under half throttle, it'll open slightly. They're going to take a lot of seat time to get good with. Is it possible? Absolutely. We've taken some Ford Focus RSs and won their class in rallies before, but it's a lot harder to drive initially at the limit and trust what that car's gonna do, because you change your steering position a little, your brake position a little, your throttle position, it's gonna be moving that power around. Some cars have that ability to lock it in, 50-50 or 60-40 or something very solid and predictable. And in that case, that's a best possible situation, but not a lot of them are gonna really operate that way in real life. Number three, you can't disable the ABS and the traction control and the stability control and keep your all-wheel drive. Most of the time, when you start pulling fuses and you start disconnecting things so that you can drive that car hard and you can threshold brake and you can slide around corners and you can rip around and do what you want to do, you pull one of those fuses and you no longer have all-wheel drive because it's all, again, working in unison. So we get a lot of people that come out here for winter driving classes and things like that, the Volkswagen stuff, the Golf Rs, they're awesome. But if you start to pull fuses and you want to slide around and, hey, if you're going to build a race car or a rally car, you got to get rid of some of this stuff. All of a sudden, it's not feeding that electronic all-wheel drive clutch pack information, so it's just off, and you've got a two-wheel drive car. If you watch the episode where we tried to rally the Mini Countryman, when you pull those fuses, it turns into a front-wheel drive car, which is fun. That's kind of a neat option to have in your back pocket. But say you had a Mini Countryman and you wanted to go rallying, you're going to need to get rid of some of that DOT safety system stuff. And there's going to be more complicated workarounds trying to get all-wheel drive to work with none of that other stuff on. And number four, they're not very easily tunable. Some of them are, there's some apps. If you've got a BMW, you can get in there and play with stuff and tell it what you want it to do. Other ones are really kind of sealed from the factory. You can't just plug a laptop in and say, hey, when I'm full throttle, lock it up. And I would probably tune it differently than you might, than your neighbor might, than the next guy that shows up at a race or something like that. But that tunability is really important if you get into, higher performance driving. Again, you're on a track, you're drifting, it rains, you're in the snow, you want to go on the gravel, whatever it might be. With a mechanical all-wheel drive system, you can change that center diff. Something like the car behind me, there's probably 30 different options, whereas an electronic all-wheel drive car, it is what it is, and only some of them are tunable. Can you have a little fun with them? Sure, you can slide around a little bit, you can get out in a parking lot, you can do some track days. We're not saying that they're bad for all performance driving, just depends how serious you are and how hard you want to push it, because at some point they're not going to be viable anymore unless you're replacing the entire transmission, replacing differentials, and swapping in, most likely, a heavy-duty, more mechanical all-wheel drive system. Which segues us nicely into that world of true mechanical all-wheel drive. You know, what are the systems that you see out there most commonly? You will see some all-wheel drives with open center differentials. A lot of SUVs and older vehicles, you know, some had open center differentials with the ability to lock. You know, older Land Rovers, the early generation Quattro stuff, you know, all the Sport Quattro stuff, Audi 4000s, 5000s, that kind of thing back in the day. Open diff, push a button, it would lock. You know, that's really switching from all-wheel drive, which is a variable amount of power front to rear, to true four-wheel drive. When you lock that center differential, those shafts are directly connected, meaning you really can't drive it on pavement very much like that. Tires are going to be hopping and skipping, going around corners. It's going to understeer an awful lot if you try and drive quickly. So these car manufacturers had to come up with something better, and really what they started using is just limited slip differentials in the center. And there's a few different ways of doing that. The common one that you're going to find, particularly with most of the modern Audis, is a torsion type helical gear type differentials. Other brands that manufacture these are, you know, Quaife and WaveTrack, and there's a bunch of them out there. There are some great websites and videos here on YouTube that are going to explain those really well for you if you're interested in how exactly those work. But from a driver's perspective, you know, that torsion center differential, torsion is torque sensing. So again, as you're on throttle, if the front drive shaft tries to turn faster than the rear, it's going to start to lock up and function like a good limited slip differential. It's really kind of a one-way limited slip differential, meaning that it only kind of locks up on the throttle. You'll get that binding and kind of that really good all-wheel drive that Quattro is pretty well known for. The one caveat to that is when you do let off the throttle, those shafts are kind of free, and certainly under braking, it's easy, you know, in a lot of these Audis to lock the front tires up while the rears are still turning. When you're even in gear, which means that front shaft is turning slower than the rear shaft is still rolling along. Also, engine braking, you know, going down a steep hill when you put it in a low gear and it's snowy and it's icy and you're just trying to get home in one piece, that all-wheel drive system isn't as tight as when you're on the gas hard. So that's just something to be aware with those, you know, helical gear type differentials. They're kind of a one-way diff. They really only work well under power. Some will work a little bit like a 1.5-way diff. You know, some of them do have good engine braking, going down hills and things like that. And when you brake, you can feel that all-wheel drive is helping the front tires not just lock up while the rears are still rolling along. It's not going to work as well as, you know, a true four-wheel drive vehicle, something with a locked center differential or just a transfer case, but it's going to work okay. This is where a viscous coupling has a bit of an advantage. You know, a lot of vehicles have an open center differential and a viscous coupling. That viscous coupling is essentially just a bunch of plates suspended in viscous fluid, and again, as one shaft, the front shaft, tries to turn faster than the rear shaft, that causes friction, and that viscous coupling binds up and basically creates a limited slip differential. The thing about viscous couplings is when they're new, they're fantastic. They lock up pretty well. It's got a lot of that limited slip, really good all-wheel drive, you know, feel about it. You'll get around like a tank in the wintertime. It's going to be wonderful. But even just normal driving, they start to wear down. Even at, you know, 50, 60,000 miles or something like that, we've seen cars with viscous couplings out here that will just spin either the fronts or just the rears, and you know, it's really acting like that open differential is just doing its thing, and the viscous is kind of burnt out. So they're definitely a wear item. And the harder you are on your vehicle, if you're doing handbrake turns, if you're rallying around, if you're driving aggressively in the winter time, that viscous coupling is going to wear out, you know, pretty quickly. And you can feel it happen. You get out in the winter in the snow and ice and you'll feel just the rears spinning a little more than the fronts, or vice versa. Again, when you brake, you'll feel the front tires are able to lock up and the rear tires are still turning, whether it was abused and driven hard in the past, or probably, you know, hey, maybe you did it. Really good test. If you're shopping a used Subaru, definitely do it in the winter if you can on the ice, because a lot of these are burnt out from, you know, kids doing handbrake turns, WRXs, things like that. That viscous coupling is useless, and the car is going to drive just like it's got that open center differential, which it does have. It's not going to be very all-wheel drive at all. we go through a lot of viscous couplings here at the Rally School. We do weld some center differentials as well. This one, driving it just up here to film this video, I noticed making a tight corner, the tire's hopping and skipping a little bit. So this is a real four-wheel drive car at this point now with that welded center diff. For a rally application, that's very common because it's going to essentially last forever, cost nothing, and driving on gravel and snow, you can get this thing turned in with just a little bit of technique. It takes that mechanical kind of fragility and weirdness out of the equation. Would you want to take something with a locked center diff out on pavement and drive it to the grocery store every day? Absolutely not. Again, a tight parking lot or something like that, it's going to behave just like a four-wheel drive pickup truck. It's going to be hopping and skipping and chattering. It's hard on axles and U-joints and all that kind of stuff. It's not really good for it. But if you were thinking about, really rallying something or getting out there, a solid welded center differential is of course an option. There are also clutch plate style center differentials. We've got another video that I did this spring on, one-way, 1.5-way, and two-way clutch style limited slip diffs. For most common applications, they are available. You can get them, swap them in. There's different ramp angles. Many of them are adjustable, and they do wonderful things. The only thing we haven't touched on is, the STIs and some of the other DCCDs, the driver-controlled center differentials. That's basically an electronic system, but it is a mechanical unit that you can adjust how locked up it is from, basically functioning as an open diff to tighter and tighter and tighter to the point where it's basically 50-50 front-rear. There aren't many of those on the market that really do what they say on the box. Subaru is one of those ones, and definitely give one of those a try if you have the chance. Drive one kind of quick, see what it's all about, take it out in the winter time, have some fun with it. A lot of the other vehicles that you see with the sand, snow, mud, rock, they're not actually doing a huge amount, and a lot of that is changing the ABS parameters and the traction control parameters and some of the other dynamic stability control systems. It's not just engaging that all-wheel drive more or less. So that's kind of all we got for you on the electronic versus manual all-wheel drive systems that you're going to see out there. If you're shopping around, if you're looking at stuff, really dive into exactly what your make model it is, exactly what's going on with that all-wheel drive system. If it's electronic, see if it's got a feature to lock it in. Whether you can get it to be 50-50 or 60-40 all the time, that's going to be a pretty good performance vehicle for you. If it's always varying power and it's changing from front to rear to all on a whim based on sensors, that can be a fantastic vehicle. Again, if you live in Massachusetts and you go on a couple of ski trips a year and you just want to feel safe doing that, that's a wonderful choice for yourself and your family probably. But as you move up that spectrum of doing more and more performance driving, driving hard, sliding around, doing some rallying, aggressive driving, it might make sense to go for something with a real mechanical all-wheel drive system. So thank you as always for watching. If you've got any questions on any of this stuff, please feel free to ask them in the comments and we'll get to those just as quickly as we can. I know I glanced over a lot of the very technical mechanical information. That's not really the goal of this video. Hopefully you can see that this is more a driver's perspective. If you've got to get behind the wheel of something, if you've got to select a vehicle for real hard use, that's where our expertise is, and that's where a lot of people are doing a much better job of taking differentials apart and showing the bits and pieces. So you're gonna have to do some of that research on your own if you're really interested in those mechanical details. If you'd like to come out and do some driving with some professional instruction, some car control, some drifting, some sliding around, high performance driving, check out teamoneil.com. We've got courses running all year round up here at our campus in New England. If you like these kinds of videos, please take a look at our channel. We just passed 200 videos uploaded, so there's a ton of good content pertaining to mechanical systems as well as driving technique and some high-speed stuff in there. Have fun, be safe, and we'll catch you next time.